Good morning, ma'am. My name is Shiva. I am from CSC section in SRIT College. My topic name is about Hamming code. Introduction to Hamming code. Hamming code is a error correcting code used to detecting and correcting single bit errors in binary data. It was developed by Richard Hamming in the late 1940s as a method to improve the reliability of data transmission. Understanding Hamming code is essential for students in electrical and electronic engineering as it forms the basis of many communication protocols. Importance of error detection. Error detection is crucial in digital communication to ensure data integrity during transmission. Single bit errors can occur due to noise, interference, or hardware malfunctions. Hamming code provides a systematic way to identify and correct these errors, ensuring data reliability. Basic concept of Hamming code. Hamming code works by adding redundant bits of the original data to enable error detection and correction. The number of redundant bits required depends on a length of the data bits and the number of errors to be corrected. The code is structured in such a way that each parity bit checks a specific combination of bits in a data. Structure of Hamming code. The Hamming code uses a formula to determine the position of parity bits within the data. Parity bits are placed at positions that are powers of 2. Example 1, 2, 4, 8, etc. in the encoded data. The remaining positions are filled with the actual data bits, creating a balanced structure for error checking. See, this is example encoding process. To encode data using Hamming code, determine the number of parity bits needed for the data length. Place the data bits into appropriate position, leaving the parity bit position empty. Calculate the parity values based on the even or odd parity method and fill the parity bit position accordingly. Decoding process. The decoding process involves receiving the data and checking the parity bits for errors. By recalculating the parity bits and comparing them to the received values, the presence of errors can be detected. If a error is found, the bit position can be identified and corrected using the parity information. Example of Hamming code. Consider a 4-bit data, example 1011, to illustrate Hamming code encoding. The necessary parity bits are calculated and inserted, resulting in a 7-bit code. The original data and the code word can then compare during transmission to detect errors. Limitations of Hamming code. Hamming code is designed to correct only single bit errors, which limits its applications for multi-bit errors. It requires additional bits for recognition, which increases the overall data size. For systems with higher error rates, more advanced error correcting codes may be necessary. Applications of Hamming code. Hamming code is widely used in computer memory system to ensure data integrity. It is also implemented in communication protocols to ensure a reliability of data transmission over networks. Understanding Hamming code is fundamental for engineers working in fields involving data storage and transmission. Conclusion: Hamming code is a significant innovation in a field of error correction, allowing effective detection and correction of errors. Its systematic approach and simplicity make it essential topic in electrical and electronic engineering. Mastery of Hamming code lays the groundwork for understanding more complex error correcting techniques in digital communication. Thank you, ma'am.